Okay, number one, we need to solve by factoring. So I need the factors of 12 that subtract to give -1. The factors of 12 are basically 4 and 3. So this is going to be x and 4, x and 3. Now it has to be a -1, so I need -4 and a +3. Put equal to 0. So x minus 4 equals 0, x plus 3 equals 0. This is going to be x equals 4. This is going to be x equals -3, and those are my two roots. The second one, you got to move the 20 over, make it a 3x squared minus 7x minus 20 equals 0. Now I'm going to do this as a Punnett square. You get 3x squared and the minus 20. All right, so the 3 times 20 is 60. So I need the factors of 60 that subtract to give -7. And those are 12 and 5. So 12x, 5x. And because I need the -7, that means the 12 has to be larger. All right, so now I'm going to pull out what they have in common. So 3x squared and -12x squared have a 3x in common. Now, from here, it makes it easy because 3x times x is 3x squared. X times 5 gives me 5x squared. 5 times -4 gives me -20. So now I'm left with x minus 4 times 3x plus 5 equals 0. Take both, set them equal to 0. And to save a little time, this is x equals 4. This turns out to be 3x equals -5 because I moved the 5 over. Divide by 3, and x is equal to -5 over 3. All right, there's the answer for the first two problems. Problem number 3. Move this 4x over, and you get 4x squared minus 4x minus 3. I'm going to use divide, reduce, swing here. So in this case, I want to take the 4 to the back, and I get x squared minus 4x minus 12 equals 0. Now in here, I want the factors of 12 that subtract to give 4. That's a 12 there. And those are 6 and 2. So this is going to be x minus 6, x plus 2. Now, when this happens, this is where the divide, reduce, swing comes into play. Remember, you took the 4 away in the beginning. You got to bring it back. This reduces down, so that's the divide part. Now we have to do the reduce part, and this reduces down to 3 over 2. This reduces down to 1/2. A lot of kids have a problem because they put that as 2. All right, now I'm going to put each one of those equal to 0. Or actually, I can either put them equal to 0 there, or I can just bring that to the front, and I get 2x minus 3, and then of course 2x plus 1. Notice I swung both of those to the front, and of course equals 0. When you put them both equal to 0, 2x minus 3 equals 0. 2x plus 1 equals 0. This turns out to be x is equal to 3 over 2. This turns out to be x is equal to a -1 over 2. Now those are the first three problems, and we have recorded for 3 minutes. Okay. Now let's go to problems 4, 5, and 6. Problems 4, 5, and 6 says take the square root of each side. This is our square root plus minus. Now on this one, a lot of kids are wanting to do this. You cannot do that. You cannot distribute into a square. So you have to divide everything by 3. You get x minus 2 squared equals 7. Now, square root, plus minus. All right? So you get x minus 2 equals 7. Here you have two equations. X minus 2 equals root 7, and x minus 2 equals negative root 7. Move that 2 over, and you get x is equal to 2 plus root 7. Move that 2 over, and you get x is equal to 2 minus root 7. Okay, and those are your two answers. The next one is simple. You just square root, because the square root's already isolated. So x equals plus or minus the square root of 225 is 15. On this particular one, again, you got to move the 4 over. So when you add the 4, you get x minus 6 squared equals 24. From that point, you're going to take square root, x minus 6 squared equals, now the square root of 24 is the square root of 4 times the square root of 6. That makes that 2 root 6. So plus or minus 2 root 6. All right, oh, I made a mistake. I haven't done the square root yet. So this is 2 root 6. So square root, well, I guess I did, didn't I? Well, that's what I get for going too fast. All right, so this turns out to be x minus 6 equals plus or minus 2 root 6. Let me take away that. Let's see there. All right, now I'm on track. That 6 add to the other side, and you end up getting x is equal to 6 plus 2 root 6, and x is equal to 6 minus 2 root 6. And again, those are my two roots. So you can just leave it like that. Okay? All right. Let's see how long I've recorded for. 5, almost 6 minutes. I guess I'll do these and then I'll stop and then I'll record another one. Now we're going to complete the square. In this case, remember, move the 1 over. So I get x squared minus 4x equals negative 1. Now, in this case, remember, you're going to take half of b, and this is your b value. You're going to take half of that and you're going to square it. So half of negative 4 is 2. 2 squared is plus 4. Okay? So this factors into x minus 2 squared, because this is, if you haven't realized yet, this is x plus b over 2. Okay? All right, so x plus b over 2 squared. So whatever b over 2 is goes right here in the parentheses. Okay? Now, equals 3. And at this point, since we are solving, we're going to take square root, x minus 2 is equal to plus or minus root 3. So x is equal to 2 because we're moving the 2 over, plus root 3. And x is equal to 2, make that a 2, oops, minus root 3. Okay? I'm going to do number 8 for you real quick. It's already set up, so I need to add a little space. X squared plus 2x equals 7. So half of 2 is 1. 1 squared is 1. Remember, half of 2 is 1, and you square it. So we're going to add 1 here. So this is x plus 1 squared equals 8. Square root, x plus 1. Now the calculator can simplify the 8 for you, and it turns out to be plus or minus 2 root 2. Okay? And you end up getting x, when you move that 1 over, the x is equal to negative 1 plus 2 root 2, and x equals negative 1 minus 2 root 2. Okay? So there are my two answers. And I forgot to do these as well. All right, and finally the last one. Switch these two, and you get 2x squared plus 10x equals 42. Now, because all three of them are divisible by 2, you can just do that. Now, we're going to take half of b. Half of 5 is 5 halves. Square it, and you get 25 over 4. All right? Now, this becomes x plus 5 over 2 squared equals 21 plus 25 over 4. Turns out to be 109 over 4. Now we're going to take the square root of both sides. X plus 5 halves equals, can't take the square root of 109, but you can take the square root of 4, and it's plus minus. So when I subtract 5 halves on both sides, you get x is equal to negative 5 over 2 plus or minus the square root of 109 over 2. Now, because they have common denominators, you can write it as two separate answers. X is equal to negative 5 plus square root of 109 over 2, and x is equal to negative 5 minus the square root of 109 over 2. Or you can just leave it like this. So either this answer or both of these answers would work. Okay?